Let me give you another example besides a battery, because it's kind of hard to think of a battery as being spontaneous in the opposite direction. Batteries don't reach that point, but some processes do. So for example, let's say that we're looking at water melting. Okay, so let's say we're looking at H2O, solid, H2O, liquid. Okay, so this is the melting of water. Okay. If delta G is less than 0, then this is spontaneous. Now, let's think about that. When does ice melt? At what temperature? The melting point, right? 0 degrees centigrade. What other temperatures would ice melt at? Temperatures greater than 0 or less than 0 degrees centigrade? I know this is an obvious question, but I just want you to be thinking here. So ice would melt at 0, start melting at 0, but they would also melt at temperatures greater than 0, right?
Right.
Okay, so we could also say that this is true if the temperature is greater than 0 degrees centigrade. Okay, so that's when we know that this process is spontaneous. But if delta G is greater than 0, then the reverse is spontaneous. You guys read that? That's spontan. So that's going to be true if the temperature is what? What's the reverse of this? Liquid going to a solid. The reverse direction is freezing, right?
Yes.
Freezing is spontaneous if the temperature is less than 0 degrees centigrade, right? So we can have a process that can be spontaneous in the forward direction, depending on the temperature, but it can also be spontaneous in reverse direction, also depending on the temperature. Okay, so this is an example of a reversible reaction that could be either spontaneous in the forward or reverse direction, and we would know that, or we would correspond the sign of delta G with one versus the other. Now, this is leading to a really important point, and that's one of the ways that Gibbs free energy equation is helpful, is that it allows us to predict under what temperature conditions a reaction is spontaneous. A reaction can be spontaneous. So I'm going to leave that reaction up there. And I'm going to write down the Gibbs free energy equation. Delta G, and this is what we derived last time. Delta G equals delta H minus T delta S. Okay. Let's think about this process. And what I'm going to do is I'm going to put underneath these three quantities, delta G, delta H, and delta S, I'm going to put what the sign of the quantity is for this process. Okay, so you guys got to help me, because you got to think about what these values would be. Let's first take delta H. Okay, delta H is enthalpy change, and we know that a negative delta H means that a reaction is exothermic, and a positive delta H means that a reaction or a process is endothermic. Exothermic is doing what? Releasing or absorbing heat. Right. So a negative delta H, exothermic, means that a reaction is releasing heat. Positive delta H, endothermic, means a reaction is absorbing heat. What has to be going on here in order for ice to turn into a liquid, for ice to melt? Does it have to be absorbing heat or releasing heat for that to occur?
Absorbing.
Right, because it has to absorb energy, so the energy in the solid can go into the motion of the liquid. It's got to absorb kinetic energy. Because it's got absorbed kinetic energy, what's the sign of delta H? Is it positive or negative? It's got to be absorbing the energy.
Positive.
Endothermic, right. Delta H is positive. Now I'm going to look at the sign of delta S. And what I'm leading towards is being able to come up with the conditions of temperature that will cause delta G to be negative. Because if I want this to be spontaneous, then I'm going to want delta G to be negative. So now I'm going to do the same thing with entropy. For this process, is the change in entropy positive or negative? Remembering that entropy means how random a system is.
Positive.
Right.
Oh, positive.
Why do you say positive?
A liquid is more random than a solid.
Than a solid, right. Liquids are always more random than a solid. So for something to go from a solid to a liquid, that process has to involve an increase in randomness, increase in entropy. Okay, so in this particular process, we know that the delta H is positive and delta S is positive. Can this expression ever be a negative number? We're starting out with a positive, but we're also subtracting a positive from it. Can that combination ever come out to be a negative number?
Yeah.
Yes.
How would it be negative? If we're starting with a positive delta H, but we're subtracting a positive, in what way can that become negative?
The second.
Delta S is larger
Second term
than delta H.
has to be bigger. Yeah. So this whole term here, including the temperature multiplication, that combination would have to be a bigger positive than the delta H for this whole expression to be negative. So we can make this negative, but it's under certain conditions of temperature. And those conditions are either high or low. When you're answering a question about what's the condition of temperature for something to be spontaneous, the answer is either high or low, or never, or always. Actually, there's 4 answers you could have. But under this particular condition, it can be negative. But what conditions of temperature favor that being negative? The higher the temperature or lower the temperature? We want this whole term to be bigger than that whole term. So we want larger temperatures, right? So this is negative at high temperature. What did we just say about ice melting? Process goes forward under what conditions?
If the temperature is above 0 degrees centigrade.
Above 0 degrees. Same thing as saying at high temperature. Now this is a relative phrase because you're not really saying what temperature it is. You could calculate what the temperature would be, but we'd have to have more information. But at least we can just, even if we weren't familiar with a process, if we know the sign of delta H and delta S, we can predict from Gibbs' free energy equation what conditions of temperature would make the process spontaneous, if at all. Sometimes a process can never be spontaneous at any temperature, simply because of the combination of the signs of delta H and delta S. Sometimes it's always spontaneous, regardless of the temperature, but it could still be more spontaneous at higher temperatures. So there's actually 4 combinations of the delta H and delta S that you could look at. But I wanted to take a concrete example so you know where I'm going with this.